So if you'll notice, your notes are kind of all over the place. So I am putting sections 5.1, 5.2, 5.3 together. We're going to jump around and go out of order. Essentially, most of this is going to feel like a review for you from Algebra 1. So we're going to hit the basics today of polynomial functions, adding, subtracting, multiplying, and dividing. But we're going to start with some vocabulary that you need to memorize for polynomial functions. And one box that I didn't put on here that I want you to put is you also need to be able to name your polynomials by the number of terms that exist. So if you'll just add that column to your notes, that would be helpful. And you should have learned this in Algebra 1. I guess we'll see how well you've retained it. But two things about polynomials. You need to be able to name it by terms, and I'm going to give you a hint on terms. When you name a polynomial by terms, the ending is always omial, okay? So omial, and then your prefix is going to depend on how many terms exist there. And then the other way we're going to name it is by degree, okay? And degree means sort of like what you see on a graph. So for example, if it has a degree of 1, and anytime you're figuring out degree, it is your, so let me just put this up here so we have it. It is your exponent that exists on the variable. And it's always going to be the greatest exponent that sits on a variable. Has to be on a variable to have a degree. So degree is like a linear function, a quadratic function, a cubic function, and so forth. So let's look at this first one. On the first one, do I have any variables right here? I do not. Okay, so this is a degree of 0. And you actually know what this is called. What is a number called that does not have a variable attached? Yeah. It is a constant, yes. So this is called a constant. And then I just put this leading coefficient just to remember we want to put things in standard form, so we want to know which one would be our leading coefficient. Well, in this case, that's pretty simple because there's only one number there. And if I were going to name this by terms, there's only one term. So what's the prefix for 1 if it's going to end in omial? Monomial, good. So monomial is our first one. Okay, so if you look at our second one, so what's the degree of this one? So you're looking at the variable. What is the exponent on that variable right there? What is it? No, the exponent, a 1. So you're looking at exponents. You're not looking at leading coefficients. Those are not the same. Degree of 1. Now think about on a graph, what would 7x minus 3 look like on a graph? I hear a lot of mumbling. What are we saying behind our math? Yeah, it looks like a line. So what do you call that? Linear. Very good. And in standard form, what would be the leading coefficient? 7. And how many terms does this one have? Very good. 2 terms. So we call that a binomial. All right, let's look at the next one. What's the degree on that third one, Wiley? Good. Greatest exponent on the variable is a 2. And we just finished this chapter. What's this function on a graph? If you name it by degree, somebody new. Maria. It does make a parabola. What do you call the function? You want help? Yeah. Ethan? Quadratic. Yes, quadratic. And the leading coefficient of this one in standard form, go ahead and tell me out loud. 4, very good. How many terms are we looking at here? 3, what do you call that? Good, trinomial. All right. the degree of the next one? Again, you're looking for the greatest exponent. Jack? 3. That is correct. Do you know what that is called? Anybody know what this one's called? It does go like this. No, it goes like this. No, it goes like this. Oh my gosh, what is happening? It'll hit the x-axis 3 times. So it'll be like boop, boop, boop. Do you know what that's called? Not a swoop. Cubic. Whoa, kind of. And what's the leading coefficient of the first term for this one? -13. How many terms does this one have? 4 terms. You know what you call that? 4 or more is always called? There you go, polynomial. So anytime it's 4 or more, you just call it a polynomial. All right, now I'm tricking you up a little bit. Why is this one different? Bailey? Okay, so this is, we would say it's not in standard form. Can somebody put it in standard form for me? What would it look like in standard form? Wiley? Okay, very good. Now, what's the degree? 4. Anybody have a guess? 3 was cubic. 4 might be ending in an ick. Nope, close. What's another 4? If you sing in a 4-person quartet, so this is a quartic. So the leading coefficient would be what? 5. So remember, you got to get it in standard form. And how many terms are we looking at? 3. So we call that trinomial. Okay, last one. Is this one in standard form right now? It is not. Can somebody put it in standard form for me? Lucy? Good. So what's the degree of this one? Degree of 5, greatest exponent on the variable. And, anybody have a guess? Quintic. Good. Leading coefficient, -11, 3 terms again. So we call that a trinomial. Okay? So these would be the terms that you need to have memorized. You need to have memorized 0 through 5 degrees, and then 1 through 4 or more, because 4 or more is going to be a polynomial when you're naming by term. Yes, Wiley. It would probably just be one question, and I would say, put it in standard form, tell me the name by degree, tell me the name by terms. Okay? It would just be like one of those, yeah. But it probably wouldn't be like a table. Okay, so last thing, just to remember about polynomials. You cannot have variables in your denominators, and you also can't have radicals or square roots or cube roots or whatever. Okay, and that's all we're going to do with the vocabulary right there. So that's your 5-3 right now. The rest of 5-3 we're going to hit when we do graphing. So that's it for 5-3. Just know the vocab, okay? So now we're going to move to 5-1, where we start looking at some operations with polynomials, okay? Now, I'm not going to talk much about this table because this is technically Algebra 1. So this is your reference. If you need it, as we're doing examples, go back to it. It is just a reminder of things that you do with rules of exponents. And here's my suggestion. If you don't have them memorized, you need to memorize them. That's your best bet. So some of them are not super logical, so just memorize. So a couple things. Remember, you can only, with exponents, let me just say this, your bases have to be If your bases are not the same, you cannot do anything with the exponents. That's number one. Okay? The product rule is keep the base the same, add the exponents. Quotient rule, keep the base the same, subtract the exponents, top from bottom. Negative exponent rule, flip the base. Either it's on top and goes to the bottom, or it's on bottom or goes to the top. Raise your hand if you remember those first three. Do we remember the first three rules of exponents-ish? Okay? Power to a power, multiply the exponents. Power of a product, that just means if I have more than one thing inside the parentheses, I distribute the exponent into both. Same thing for power of a quotient, I distribute into both. And then always remember, anything to the 0 power, the entire thing becomes a 1. So x to the 0 power is 1. 7 to the 0 power is 1. You always want to change that in your problems. Okay? Does anyone have a question about that before we just start doing some examples? All right. So I'm going to keep this, or skip the explanation. We're just going to go right into simplifying. One reminder, anytime you are done, make sure you never, ever have negative exponents in your answer. Okay? So that's important. All right, so we're going to simplify each expression, assume that no variable equals 0. So we're going to start with the first one. So on this first one, when I'm dividing, I can deal with the bases are the same. So I'm going to deal with the q to start. And when you're doing division, what do you do with those exponents? Subtract. So I'm just going to write it out just so I can see it. So I'm doing 2 minus 7. And then I'm going to deal with my r's that are the same. So I have r to the, I'm going to subtract 4 minus 3. And then I'm going to simplify that. So I would have q to the negative fifth, r to the first. Now, can I leave my answer like that? I cannot because of the negative exponent. So which one of those bases has a negative exponent? The q. Okay, so here's what you need to remember. The question is that q on top or on bottom? Well, if there is no bar there, we know that all things exist as a fraction. How? How do all things exist as a fraction? Over 1. So all of this right now, even though I don't see it, I know exists over 1. So to get that exponent to become positive, I'm going to take that q down to the bottom. Okay, so that would give me r to the first, which I'm just going to write as r, over, that becomes q to that, now it's a positive 5. There are no negative exponents, so I am done. Okay, does anybody have a question on that? All right, let's do the second one. Now, the second one, these are all squeezed together. So we're going to multiply things that have the same base. So I'm going to start with my constants. If I have constants, I can always multiply them together. So 2 times 3 is 6. Now, I'm going to multiply my bases are the same. So I'm going to multiply a to the negative second times a to the third. What's the rule that you do with those exponents? You add them. And I'm just going to write it out so we can see it. Is there anything to multiply with my b? Nope, so bring it down. Anything to multiply with my c? Nope, so I'm going to bring it down. Okay? Then I'm going to go ahead and simplify. What's negative 2 plus 3? 1. So I have a 6, I have an a b to the second, and a c to the negative 2. Can I stop there? I cannot. So I have a negative exponent. What's the only base that has the negative exponent? The c. So again, remember, this would like it's all over 1, right? So the c has to move to the bottom. And that's the only thing that moves. So on top is 6a, b to the second, over c to the second. Remember, when you move it to the bottom, it becomes a positive exponent. All right, I'm going to do one more with you. Then I'm going to turn you loose on a few of these. Okay, so here we go. Let me show you the biggest mistake that I see. When I have multiple things inside parentheses, the mistake I see is that you don't take the exponent into everything. So here's what I need you to understand. That -2 is squeezed, but I could separate it by putting what operation there? A multiplication. So this 3 has to go to the -2 and the A and the B. And what most people do is they take it to the A, they take it to the B, and they think they're done. Okay, so here's what we have. That -2 is inside parentheses. I have to leave it inside parentheses. And then I have A to the, what do you do with those exponents when you take the exponent into the parentheses? You do not add. Multiply. When you have a power raised to a power, that's multiplication. So that would be A to the 12th over B to the 6th. And the last thing we're going to do is simplify that number right there. So what would -2 cubed give us? Yeah, -8. So I have -8, A to the 12th over B to the 6th. Do I need to move anything? Do I need to move that -8? Why not, Rhea? That's right. Negative coefficients are completely fine. You just can't have negative exponents. So there would be my answer. Okay, so here's what I want you to do. I want you to do the next 3. And as you do them, I want you to check with people around you. And we're going to see how we're doing, what mistakes we're making, and so on. And find somebody around you and do all 3 so you can check all 3. Check. Just make sure you check with somebody. Yep, just go ahead and simplify your 4 to the 3rd. second. You got good discussions. It sounds like there's some discrepancy on the last one and maybe the second to last one. So how did we do on this one? Did we get negative 14 x to the second, and then on your denominator or in your denominator you should have y cubed? Did we have that one right? Okay, so that's good. Multiplication you seem to be good with. Okay, so this one I walked around. There were a couple issues. Number one, I saw some people forgot. So remember, that negative 2 is raised to the first, right? So next one of 1, I got to take that in. Some of you forgot that. So that's negative 2 to the 5th, x to the, remember, you're multiplying, product to a product, we're multiplying, x to the 15th, y to the 10th. And really on this one, all you had to do was just simplify that, and that's a negative 32. I saw a couple of you had a positive. Should be a negative right there. And that stays, because that's a negative coefficient. That has an exponent of positive 1, okay? How did we do on that one? Did we get it? All right, the last one. So, again, I'm going to take it in here. And remember, when I'm taking it here, I'm taking all of these to an exponent. I'm not multiplying the 3 and the 4 together. I'm taking it as an exponent. So that's a to the negative third over 4 to the negative third. Right? Now, what happens on this one? Yes, both of them have to go. A has to go bottom, 4 has to go top. So that's 4 to the third over a to the third. And then you would just do that. What is 4 to the third power? So your answer is 64 over a cubed. Okay? Who got that one? Did we get it? Okay. Okay, any questions for me on simplifying? All right, now degree. So we did degree at the beginning when you only had one variable. So now we're going to look at how would you find the degree if I have multiple variables, okay? So with this one, we're first going to be able to answer, is it a polynomial? So remember those stipulations we had on the front page of what can't be a polynomial and what can. And then if it is, you're going to tell me the degree. So looking at the first one, is this one a polynomial? Why are you saying no? Yes, you cannot have a variable in the denominator. That is correct. So this is not a polynomial. That should not say on. It should say in. Oh, only I wrote demon. Yes, denominator is the bottom. So like that y. Okay? Now how about the next one? Is this one a polynomial? Yes, it is. Everything is just being multiplied together or adding and subtracting. So this is a polynomial. Now, I'm going to help you. When you have more than one variable, this isn't as simple as saying, oh, the degree is 5. The degree is actually the sum of the two variables' exponents. And it's always the greatest, just like we did earlier. So what's the degree on y? A 1. So that would give me what for that term right there? 6. And what would this one be? 7. So you pick the largest. And so this would be a degree of 7. And you're not going to see that very much. But I at least want you to be exposed to it so you know if you get something like that, what the degree would be. Okay? All right, so let's turn your notes over. Now we're going to add and subtract. Reminder, when you add and subtract, you only add and subtract things that are alike. So, let's have somebody, actually, I want you to do both of these on your own because I think we can do these. And then I want you to check up here and see if you got them right. Just a reminder, when you do subtraction, be sure you subtract off the entire quantity to the right. In other words, distribute that subtraction sign through. And write your answer in standard form. All right, let's look up here. Did we get these two answers? So we have 3x squared minus x minus 5. Give me a thumbs up if you got it. And then the second one, negative 2x squared minus 5x minus 1. Give me a thumbs up if we got that one. Did we get that one? Okay, just to practice, name this first one by degree. It is a 2. What's the degree? What do you call it by degree? That's by term. Degree is graph. Think graph, right? Quadratic, okay? Name it by terms. Good. 3 terms is trinomial. And then we won't do that one over there because that's identical, right? Degree of 2 is a quadratic. 3 terms, trinomial. Okay, that's going to be the biggest thing is remembering the vocab for degree versus number of terms. Okay, so keep those straight. All right, let's go down to multiplication. Go ahead and do the first one. Do not forget your rule of exponents when you multiply here. So, for example, what are you going to get when you multiply negative 2a times negative 3a squared? Good. 6a cubed, because remember the rule is if the bases are the same, we add those exponents. So that's going to be 6a cubed. Okay, you can continue that one. And you should have gotten 6a cubed plus 22a squared minus 40a. Reminder, make sure your answers are written in standard form always at the end. Okay? All right, we're going to do the same thing here. We're just going to distribute a fraction through. So 4/3 times 6. So remember, 3 goes into itself once and into 6 2 times. So what does that give us? 8. What? X to the 4th. Good. And now we're going to do 4/3 x squared times 9x. So again, 9 would be on top, 3 is on bottom. 3 goes into itself once and into 9 3 times. So what does that give you? 12. Good. X cubed. And then lastly, when I multiply 4/3 times negative 12, again, 3 goes into itself once and into 12 4 times. So what does that give me? Good. Negative 16 x squared. None of those are alike, so I cannot add and subtract them, so I am done. Okay? Any questions there? All right. We are going to look at a word problem. And I am going to see if you guys can come up with this equation. So I'm going to have you in your seats find a partner. We're going to read it, and then I'm going to have you talk it through and see if you can come up with this equation. So all this is asking for is to write a polynomial. That's all we're doing. Write a polynomial. You're not solving for anything. So here's what it says. Paul has $900 to invest in a savings account that has an annual interest rate of 1.8% and a money market account that pays 4.2% per year. So again, I want to draw your attention. This is the total amount of money that he has. Write a polynomial for the interest that he will earn in 1 year if he invests X dollars in the savings account. Fire up your brains and find someone to chat with and see what we can come up with. And go. Some of you aren't finding a person to talk to. Help each other out. You can do 3 if you need to. Okay, real quick. How do you put percents into equations? You put them as what? Decimals. So what is 1.8% as a decimal? 0.018. Yeah. So just make sure you don't plug it in as 1.8. That'd be a heck of an interest rate. Okay, I hear some good talking over here. So let me ask you a question. So you know that you want to take your interest rate times whatever you're investing, right? Okay. So how much are we investing in savings? X. Now, the question is, well, how much are we investing in the money market? But what do we know that can help us? Yeah, I know what my total is. So whatever I invest in that savings account, I can't go above 900, right? That's all I have. So whatever I invested in my savings, 900 minus that is going to be what I put in my money market account, right? Okay, now how can I set up an equation based on that information? Wiley? And what are we missing? Is this equal to anything? What would this equal? Something we don't know. What are we trying to find? What did it say in the problem? How much what he'll earn? Interest, right? So let's just say it's equal to I, right? That's going to be how much interest he would earn. And then we can simplify that. So go ahead and distribute your 0.042 through. If you would help me out, please. What is 0.042 times 900? Say it again. 0.8. And then minus 0.042x. Bring down this x. And what's the last thing I can do? Combine what? Yes, combine like terms. Thank you. And what do we get? And there is my polynomial function for the interest he would earn. Okay? Okay, so the last piece of simplifying here is multiplication, and I am giving you multiplying a trinomial times a binomial. Normally you FOIL. In this case, we're just going to multiply through for all of them. So I'm going to show you how I do it. You can do it however you want. So if it makes more sense to you to go left to right, you can do that. I always start with my smallest, and I send it through to all three. And then I do the next term and send them through to all three, and then I combine, okay? So if I do x, I would get x cubed plus 4x squared plus 16x. Now I'm going to distribute my negative 4 through to all three, and that would give me negative 4x squared minus 16x minus, is that 64? And then we're going to combine like terms, right? So what do you notice is happening when I combine like terms here? Yes, 4x squared and negative 4x squared is going to cancel. 16x and negative 16x is going to cancel. So I'm left with x cubed minus 64 as my simplified answer. Okay? All right, go ahead and do the next one. Check it with a friend. Make sure you have the right answer. Okay, is this what we got? 6x cubed minus 14x squared plus 19x minus 5. Yes? Okay. How are you feeling about add, subtract, multiply? Are we good? All right. So we're going to do now division. There are two ways that you have to know how to divide, okay? So I'm going to tell you that on your test, I'm going to ask you to do both. So you can't just say, oh, I like this one better. I'm going to do that the whole chapter. Do not do that. It will come back to bite you on your test, okay? So the first way I'm going to teach you is long division. Do you remember long division way back in elementary? Okay, so here's what I need you to remember about long division. When you did it, you would go like, you know, whatever. Okay, 3 goes into 10. How many times, right? And you would say 3. And then you would multiply it, bring it down, and then you would subtract. Yes? Are you hearing me? You're going to follow the exact same method when you do long division of polynomials. Okay? So this is saying, okay, what is x squared plus 3x minus 40 divided by x minus 5? In other words, x minus 5 times what will give me this trinomial if I FOILed it, okay? So you're going to set it up just like you do long division. So this goes outside, x minus 5 goes outside, and then my trinomial is going to go inside. And again, it's just like how you did long division. You're just looking at the first term. So I'm saying x times what will give me x squared? Or think of it as x squared divided by x. So what is that? X times what is x squared? X. Now I'm going to take that x and I'm going to distribute it through. That's a binomial, so I have to distribute it twice. So I'm going to have x squared minus 5x. Now, I am subtracting this off, but that is a binomial, right? So just like you did earlier with subtraction, I'm going to have to take that through into both. Everybody with me? So this x squared becomes negative. That means those are going to cancel. My 5x becomes positive. So this becomes 8x. Bring down the next term, which is minus 40. Now I'm saying x times what equals 8x? 8. And then I'm going to take that 8 and I'm going to multiply it through to both, which is 8x minus 40. And then I'm going to subtract it off, right? And I'm going to take it through. So my 8x's cancel. What happens to my 40s? They cancel. So in this case, that means, remember when you did long division and you had remainders? Remainder is 0. So my answer is just x plus 8. And how could I check that? Yeah, FOIL. X plus 8 times x minus 5 better give me x squared plus 3x minus 40. Okay? May I have a question about that? Okay, we're going to do one more like this, okay? All right, so here we go. So I have x minus 1 on the outside, and then I have x squared minus 13x plus 12. Okay, so we're saying x times what equals x squared? X. And then I'm going to distribute it through. So that's x squared minus 1x. I need to just subtract that off. So I'm going to distribute it through. That's a negative x squared. So my x squareds cancel. That'd be a positive 1x. What's negative 13x plus 1x? Negative 12x. Bring down your next term. Now, x times what equals negative 12x? Negative 12. And then I'm going to distribute that through to both. So negative 12x plus 12. And I'm going to subtract those off, which means my 12x's cancel and my 12's cancel. So my remainder is 0. And so my answer is x minus 12. Yes. Nope. If you got a remainder, so let's just pretend the remainder was like 6. Then you would write plus, and you would write it like, you know how you did a fraction before? Same thing. Put your remainder and then what you divided by on the bottom. Okay? Yes? Well, the answer isn't a polynomial, but you could still find what the divisor is if you did the work. Okay? All right, anything there? Okay, so that's long division. So I only did 2 of those. Now we're going to do synthetic division. Now, here's how synthetic division works, okay? You will, I'm going to write this over here. The key to synthetic division is that you always have to be dividing by x minus some number. So the key is this. This has to be a 1 right here for this to work. Okay, and so the way you set it up is you put your r in a little bracket, and then to the right, you put the coefficients of your polynomial. And we're going to look at how you do that. So we're just going to do 2 of these. We're going to do 4a and 4d. Okay, so we won't do all 4. So I'm going to give you 1 of each, and you're going to see why. Okay, so let's start with 4a. Okay, so remember, for this to work, I have to be dividing by x minus r. Okay? What do you notice is different about what we're dividing by? Yes, this is a plus sign. Okay? So what would that make my r for that to become a plus? Had to be plus and negative, right? So if I were going to rewrite this, this would look like x minus negative 3. So my r, does everybody see that? Is really negative 3. Are you with me on what we're doing here? Okay, so in my little box, I'm going to put negative 3. Now, from there, I am just listing the coefficients of my polynomial in standard form. So we're going to write, starting with our first, a 2, then a 3 would be next, then negative 4, and then 15. Okay, then I'm going to draw a line, leave some space, and then you always bring down your first coefficient, and then I always draw a line because this will represent my remainder right here. So you draw a line separating your very last, your constant, essentially. Okay, so then here's how this works. You bring down your first coefficient. You multiply those two together. So I take 2 times negative 3, which is negative 6. Then I add these two numbers together. So 3 plus negative 6 is negative 3. Then I take that number and I multiply it to my r. So negative 3 times negative 3 is 9. Then I add those together. Negative 4 plus 9 is 5. And then I multiply 5 times my r, which is negative 15. And what does that give me? 0. So I have no remainder. So remember, these are just my coefficients. So I need to take those coefficients, and now I need to put variables to them so that I have my answer. So here's what you have to pay attention to. This time I started with an x cubed, right? What would my first term have to have here if I want this x plus 3 to multiply to this to give me an x cubed? X squared, good. It has to be 1 less than your initial, otherwise you're not going to get that out. So I'm going to have 2x squared. What would come next then? Minus 3x, and then lastly, plus 5. That's a positive 5, right? And how could I check to see if that is correct? Well, it's technically not called FOIL this time. What would you call it? Or multiply, right? So you would just multiply x plus 3 up here times all of that, and you better get out what we started with. Okay? Anybody have a question about that? Most people like synthetic division better than long division because you're just dealing with numbers. Okay, so let's look at 4D. In 4D, what is my r this time? Is it negative 2? It's just 2 because the formula is always x minus, right? So I'm going to put 2 in my little bracket thing. Okay, now I'm putting my coefficients in standard form. So I have a 6. Then I have a negative 8. Would next be the 12. In standard form, so look up here. I have a b to the 4th. I have a b cubed. What would come next in standard form? After b cubed, what always comes next? B squared. Do I have one? So what's the coefficient? 0. You have to plug that in. If you forget that, you're going to get the entire thing wrong. Then I would plug in a 12, and then after a b is a constant, which is negative 14. Draw your line, bring your first coefficient down, and I'm going to draw my bar here. Okay, so here we go. 6 times my r, so 6 times 2 is 12. Then add those together. 12 plus negative 8 would be 4. Multiply 4 times my r. 4 times 2 is 8. Add 8 and 0. I get 8. Multiply 8 times my r. 8 times 2 is 16. Add 16 and 12. I get 28. 28 times 2, 56. And what do I get when I add 56 and negative 14? 42. Okay, so now we have the coefficients. We got to put variables on them. So remember, if my first one is a b to the 4th, that's my original, and my answer, what does the first term have to be? Cubed. So I would have 6b cubed plus 4b squared. You always just follow in order, standard form. Plus 8b plus 28 plus, now I have a remainder, so you put 42 over what you were dividing by, which is b minus 2. And that would be your answer. Okay? Anything there? Hang tight, we're almost done. All right, now, I'm going to do one for you. We're only going to do one, so we're not going to do the second one. And what is the difference in this one than the ones we just did? Bailey? Yes. So remember, for synthetic to work, it has to look like a single x, a 1x. So what would I need to do to get rid of that 3? So what do you do to get rid of a 3 that's being multiplied by x? How do you get rid of it? You divide by 3. Okay, so we're going to divide everything, everywhere, by 3. Don't panic. You're going to have some fractions, but you're going to see how it works out. So I'm going to rewrite this. So I would have x to the 4th minus 5/3 x cubed plus 1/3 x squared plus 7/3 x divided by x plus 1/3. Okay, so we got to first identify what would be our r in this case. Negative 1/3. Good. My r would be, because this would be like minus negative 1/3. That's how it became a positive. So r is negative 1/3. So in that little box is going to be negative 1/3. Okay, from there, we're going to plug in our coefficients. So I have a 1, a negative 5/3, a 1/3, a 7/3, and is that it? Why do you have a 0? Yes, so there's no constant, right? The constant is gone, so I'm going to put a 0 there. All right, I'm going to draw my line, bring down my first coefficient, and I'm going to draw that line for my remainder at the end. Okay, so here we go. This is why you left it as fraction. So what is 1/3 times negative 1/3? I mean 1 times negative 1/3, sorry. Negative 1/3. You can add those together because the bottom denominator stays the same. What's the numerator going to become? Negative 6/3, which is negative 2. Now, what's negative 2 times negative 1/3? 2/3. What's 2/3 times 1/3? I mean plus, sorry, 2/3 plus 1/3. 3/3, which is 1. 1 times negative 1/3. Negative 1/3. What's 7/3 plus negative 1/3? 6/3, which is 2. And then 2 times negative 1/3 is negative 2/3. Adding 0 to it is negative 2/3. Okay? So now we're going to write, we have our coefficients. We're going to put the variables with it. What's the first variable going to have to be if the first one was x to the 4th? X cubed. So we have 1x cubed, which I don't have to put a 1, or you can, minus 2x squared plus 1x plus 2 plus, and then I have negative 2/3 divided by x plus 1/3. Now, before I circle that answer, does anybody see an issue with that answer? Lucy? Yes, I have basically a fraction in a fraction. Can't happen. Just like negative exponents can't happen. So we're going to simplify this, okay? How do you simplify? What's the rule when you have a fraction inside of a fraction? That's the ending. Keep, change, flip. So you're going to keep the top. So the top is just negative 2/3. Change division to multiplication. Flip the bottom. So what would this look like if I flipped it? Look at this as one whole thing. If I wanted to make that a fraction, what would this look like if that whole thing was a fraction? Yes, all of that would be over 1. So if I flip it, what's it going to look like? Yes. Okay, then we're just going to distribute. Negative 2 times 1 is negative 2. And then when you distribute here, that's a binomial, right? Take it into both. 3 times x is 3x. What's 3 times 1/3? 1. So now my final answer will be x cubed minus 2x squared plus x plus 2 minus, or you could say plus negative 2 over 3x plus 1. Okay? Anybody have a question about that? Okay, so we are going to stop there for now because some of those evaluate are a little, at the very last ones, a little long. So we're just going to hold on that. We're just going to work on operations of polynomials for your homework. So you have about 20 minutes to get started on your assignment. It is in Canvas. You only get one shot at this assignment, okay? One shot. So keep your notes out to make sure your vocabulary is correct before you select your answers. And if you have questions, I can be around to help you as well, okay?